Welcome. Today, we'll be exploring the design and operational principles behind one of the most fundamental building blocks in memory technology, static RAM, specifically focusing on the 6-transistor, 60 SRAM cell. This design is widely used due to its stability, reliability, and efficiency in retaining data as long as power is supplied. Our focus will be on understanding the read and write operations in SRAM, as these processes determine the speed, power, and data integrity of the memory. We'll break down the roles of each transistor in the 60 cell, analyze how they work together to store and modify data, and review the essential conditions for reliable read and write functionality. By the end of the session, you have a strong grasp of how SRAM achieves high-speed memory access, making it a preferred choice for cache memory in processors and many other high-performance applications. Let's dive into the world of SRAM design. Semiconductor memory is primarily classified into two main types: ROM, which is read-only memory, and RAM, which is random access memory. Here's a breakdown of each type and its subtypes. The first classification is read-only memory. ROM is non-volatile memory, meaning it retains data even when power is turned off. It is typically used to store firmware or software that doesn't require frequent updates. ROM is generally slower than RAM. The types of ROM are as follows: 1 mask ROM, that is MROM; 2 programmable ROM, that is PROM; 3 erasable programmable ROM, that is EPROM; 4 electrically erasable programmable ROM, that is EEPROM; and 5 flash memory. MROM is programmed during manufacturing. Data is permanent and cannot be altered after production, and is used in applications where the program is fixed. Programmable ROM is one-time programmable, programmed by blowing fuses within the chip using a PROM programmer, and is suitable for cases where the data needs to be written once and never modified. Erasable programmable ROM, EPROM, can be erased and reprogrammed using UV light. Data can be erased by exposing the chip to ultraviolet light through a quartz window on the chip, and is common in development and testing phases where data may need to be modified. Electrically erasable programmable ROM, EEPROM, can be erased and reprogrammed electronically, byte by byte, and is slower than RAM but useful for applications where data needs to be periodically updated without removing the chip. Flash memory is a type of EEPROM but can erase data in blocks rather than byte by byte. Faster erase and write times compared to EEPROM, and is common in USB drives, SD cards, and SSDs for data storage. The second type is random access memory, that is RAM, which is volatile memory, which means it loses its content when power is turned off. RAM is primarily used for storing data that the CPU needs to access quickly and temporarily while the computer is running. The types of RAM are as follows: static RAM and dynamic RAM. SRAM uses bistable latching circuitry to store each bit. Faster and more reliable than DRAM, but also more expensive, and is commonly used for cache memory in CPUs and other high-speed applications. DRAM stores each bit of data in a separate capacitor within an integrated circuit, requires periodic refreshing, typically every few milliseconds, to retain data, and is cost-effective and widely used in main memory applications. DRAM can be further classified as follows: 1. Synchronous DRAM, that is SDRAM; 2. Double data rate, that is DDR, SDRAM; 3. Rhombus DRAM, that is RDRAM; 4. Video RAM, that is VRAM; and 5. Low power DDR, that is LP, DDR SD, RAM. Synchronous DRAM: 1. Operates in sync with the system clock, and 2. Improved speed over traditional DRAM and used in most PCs. Double data rate SDRAM: 1. Transfers data twice per clock cycle, both the rising and falling edges, and 2. Available in multiple generations DDR, DDR2, DDR3, DDR4, DDR5, each with increasing speeds and lower power requirements. Rhombus DRAM 1. Was developed by Rhombus Incorporated, used a high-speed bus and was popular in early 2000s. And 2. Eventually lost popularity to DDR, SDRAM. Video RAM 1. Is a dual-ported variant of DRAM used specifically for video memory and 2. Stores graphical data and enhances rendering speed for display output. Low-power DDR, SDRAM 1. Was designed for mobile devices and offers low power consumption and 2. Was commonly used in smartphones, tablets, and other portable devices. By using ROM for long-term data retention and RAM for high-speed, temporary data storage, systems optimize performance and memory cost-effectiveness.